NASA's BioSentinel will carry microorganisms to deep space to help scientists better understand the effects of deep space radiation on biological life forms. While NASA's Artemis I mission is an uncrewed mission, there will be some living passengers on board. BioSentinel, a shoebox-sized CubeSat, will carry microorganisms, in the form of yeast, into deep space so that scientists can fill critical gaps in the knowledge about the health risks of radiation in deep space. The primary objective of BioSentinel is to monitor the vital signs of yeast to see how the microorganism fare when exposed to the radiation of deep space. Yeast cells have biological mechanisms that are similar to human cells, including DNA damage and repair. Due to this, scrutinizing yeast in space will help us better understand the risks of space radiation to humans as the space agency plans missions to the moon and beyond. For this, BioSentinel will study yeast cell growth and metabolic activity after exposure to a high radiation environment. BioSentinel is just one of the Artemis I mission's 10 secondary payloads that will hitch a ride to deep space. All of these satellites are mounted in the Orion stage adapter on the Space Launch System rocket. They will be ejected into space to carry out science and technology investigations in deep space. Among these, BioSentinel is the only satellite to carry a life science experiment. SLS will deploy BioSentinel into space within hours of launch, and a few days later, it will swing past the moon to spend the rest of its 6 to 9 month-long mission orbiting the sun. Once in orbit, BioSentinel's mission team will trigger week-long yeast studies periodically, and the satellite will send the data back to Earth using NASA's Deep Space Network. A key component of BioSentinel's mission is a novel biosensor. NASA refers to it as a miniature biotechnology laboratory that is designed to measure how living yeast cells respond to long-term space radiation exposure. It has a set of microfluidic cars, which allows the controlled flow of extremely small volumes of liquids to provide a habitat for yeast, along with a way for scientists to observe them in real time. Alongside the biosensor, the BioSentinel will carry a radiation detector instrument which characterizes and measures radiation. There is an identical set of specimens and instruments at NASA's Ames Research Center in Silicon Valley. The sets of data from space and the research center will be compared to measure the yeast's response to different gravity and radiation environments.